dire wolf is now resurrected after 10,000 years. When are they going to revive Cambaytherium? Let me guess. Cambaytherium would have been some ancient extinct Indian animal. Let's Google it. Yeah. So can there be any adverse effects in reviving extinct animals in our current ecosystem? Let's go to Google and search for these beasts: the dire wolf and Cambaytherium. So yeah, we know the dire wolf is an extinct 10,000-year-old wolf, and it's been allegedly resurrected. Two puppies. So the de-extinction of the dire wolf they're talking about. So they have revived this species allegedly. Two twin puppies have been born who look like nice little doggies, but they will grow up to be large wolves. And the wolf is obviously part of the dog species, but it's the wild version. So the dire wolf was historically it used to live in, I think, North America, I believe, and it was a much larger uh, in size than the regular wolf that we are aware of. Even the regular wolf is kind of bigger than your standard issue dog, and the dire wolf was larger than most wolves. So what they did was okay, I've not read the story, but let me tell you what I think they've done. They would have recovered a, probably a frozen specimen of a dire wolf, or some portion, some tissue of a dire wolf that would have been frozen in the permafrost. So they get the tissue, it's reasonably undamaged, the tissue, and you can extract DNA out of it. Now the half life of DNA is about 500 years, which means if you have a sample of DNA, in 500 years half of it will be destroyed, the bonds will break, so only half of it is left. Then another 500 years, half of that half left is gone, and so on. So every 500 years you have half. But yeah, 10,000 years, if it is in permafrost, it may survive reasonably undamaged. So they were able to apparently extract the DNA from that sample of the dire wolf tissue, and then you can inject it using cloning techniques or whatever uh, into a regular wolf today, and that female wolf will give birth to uh, puppies that apparently are direwolf puppies. So it's essentially a genetically modified modern wolf, and who has been given uh, direwolf genetics. That's what it is. So it's not quite the direwolf, but it's the closest thing we can have today, and it's gonna probably have most of the features that the direwolf used to have. So that's direwolf. That's how they did it. Now let's look for Cambaytherium. Let me guess, it must be some extinct Indian animal. Let's see. Cambaytherium. Okay, looks like some form of, I don't know, whatever it is. Let me go to Google. Uh, let's quickly look at the Wikipedia thing. Extinct genus of placental mammals in the family, whatever, whose fossils were found in an open pit coal mine located in Gujarat, India. Okay, so it's an extinct Indian animal. When was it alive? The fossils were dated to the early Eocene, 54.5 million years ago. Okay, how large was this thing? It would have weighed about 23 kilograms, and the smaller one was about 10 kilograms. So it's a medium sized beast, not very large. 23 kilograms is not small, obviously, and so on. So that was Cambaytherium, and it was discovered in Gujarat in western India, and this is kind of what the beast looked like. And it lived about 54-55 million years. Let's say 55 million years. Okay, we have the information we need. Now, think about it, friends. The half life of DNA is 500 years. 500. 54 million years is 54 with six zeros after it. Do you think DNA can survive that long, even in the best conditions? I would be very skeptical. I don't think it can. Once again, let's go and ask our friend Google, oldest recovered DNA ever, okay? Let's quickly ask Google, what is the oldest DNA that anybody has recovered? Oldest recovered DNA. Recovered, discovered, whatever. Okay, approximately 2 million years. Wow, that's amazing. Found in sediments in Greenland. It was extracted from frozen soil. Okay, okay, so we don't quite know what DNA it is, but they discovered some DNA. And the oldest DNA sequence from physical specimens are from mammoth molars in Siberia, 1 million years old. Well. Okay, so up to a million or 2 million, it's possible. Years. in age. 55 million years, that's almost dinosaur era. The dinosaurs were wiped out 66 million years ago, not far away from 55. So I think Cambaytherium is going to be a gigantic impossibility. Excuse me. Why? Because the remains that are available are fossilized. The bones have been replaced by rock sediments. Can you find soft tissue in there that survived 55 million years? Is it possible to recover the soft tissue, which may contain perhaps some DNA? For that, you have to break all the fossils and look within the bone cavities. Within the bones, you have bone marrow, etc., and so on. So you would have to first of all go and break all the fossils and see if there is any soft tissue left, which is almost an impossibility, but not quite impossible. Because I do remember reading this 10, 15 years ago that somebody was transporting a Tyrannosaurus Rex sample, a femur, thigh bone, and somehow the workers messed up, and the specimen which was being transported by crane, it fell, the thigh bone broke, and inside they found soft tissue, wet tissue. And when the tissue was examined, they found things that looked like blood cells. T-Rex lived 100, I don't know how many years ago. Tyrannosaurus Rex, how old is it? T-Rex, how old? When did T-Rex live? Okay, yeah, it died. It died out 66 million years ago with the extinction of the non-avian dinosaurs. So it's possible, but the probability is extremely low. But if they do discover, let's say, Cambaytherium DNA, then they could try and do something like that. Could there be adverse effects? Well, not really as such. uh, the animal that you bring back, well, let's say you bring back the woolly mammoth, I mean, where will it live? That's a question. It will be adverse for the new specimens that you are generating, because it will not have the environment it evolved to live in. The woolly mammoth went extinct about 10,000 or so years ago because of the end of the ice age and because of human hunting. It was an animal that could only thrive in extreme cold. Today we don't have it. Where will it live? And so on. The adverse effects will happen if you revive ancient viruses or bacteria. That's what we don't want. So